press the bell icon on the YouTube app and never miss another update.
Okay, my dear students, from now onwards, we concentrate purely on competitive part. In the previous regular classes, I feel that you have learned the basic concepts and a few problems based on those concepts what I have taught for you. ಈಗ ಇಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ಸನ್ನು ಸ್ವಲ್ಪ ಕ್ಲೀನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಕಾನ್ಸೆಪ್ಟ್ಸಲ್ಲಿ ತುಂಬ ಸ್ಟ್ರಾಂಗ್ ಇರಬೇಕು ಅಂತ ಹೇಳ್ತಾ ಇರ್ತೀವಿ. ಸ್ಟ್ರೇಟ್ ಅವೇ ನಾನು ನಿಮಗೆ ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಒಂದು ಕನ್ವೇಯರ್ ಬೆಲ್ಟ್ ಅಂತ ತೊಗೊಂಡಿದ್ದೆ. ಆನ್ ಎ ಕನ್ವೇಯರ್ ಬೆಲ್ಟ್ you can listen this. There are two pulleys over which a belt, this we can call as a conveyor belt. So this conveyor belt is moving with an acceleration of, say, constant acceleration of 1 meter per second square. And there is a person, say, this man of say 60 kg, when he or she stands on the conveyor belt, what force should a man experience? What is the force acting on a man? If they ask, the force on a man just by the Newton's second law of motion, what you can say, that is the downward weight. So what is the mass of the person here? 60 into downward acceleration, in the sense the man with which he is following on the conveyor belt has to move along with the conveyor belt, means that force must be acting on that person should be is equal to the acceleration with which a person is carried along with the belt. We should not put a G value 9.8. That is the concept here. So that is not the downward weight, that is equal to mass into acceleration. What is the mass here? Mass of the body 60 into what is acceleration here? 1. Many students will write m into g. No, the conveyor belt is carrying him with what acceleration? Same acceleration of that of conveyor belt. Therefore, I can say the 60 Newton is the answer. This is what to be discussed in the last class. As I said, a man on a conveyor belt is carried along with the belt with an acceleration of 1 meter per second square. Then what is the force acting on a man? The force acting on a man is m into a, that is 60 Newton. Copy this. On a conveyor belt, the force acting on a man, when conveyor belt has a constant acceleration of 1 meter per second square. 1 meter per second square. Copy this. So right, force on a man is m into a, where m is mass of the person is 60, and don't write g here because conveyor belt is moving with an acceleration of a. So force on a man is m into a, 60 Newton. Now in the same problem, you can have this. What maximum acceleration should be given to a conveyor belt so that man should not fall? A man should not fall given that the coefficient of friction between the belt, coefficient of friction between the belt and the shoes, shoes, shoes of a man is say 0.2. To what maximum acceleration to the conveyor belt is given? Means with what maximum speed a conveyor, with what maximum acceleration conveyor belt can move such that a person should not fall. Dear students, when person should not fall, you must say that there must be some static friction here. That maximum static friction is what? Mu s into mg. Here mg comes into picture, dear students. Mu fs is equal to mu into n. Mu n, we already studied this. Mu s into m. Why mu s? Because it is a static friction. So with this, what the concept is? A man should not fall anta kottidare. Andre man should be at rest. Under static situation, man is under rest, dear students, whereas a conveyor belt is in motion. That conveyor belt has some force, that is force of conveyor belt, and the force due to static friction. Static friction should balance. Force acting on a belt and the force exerted on a man due to static friction should balance so that man is at rest. Man remains at rest. Man remains at rest and there should be some balanced force or net force on a body should be zero. Net force, that is it, delta F must be equal to 0. Change in force must be equal to 0. Or I can say the force should be equated. What are the force? Force on the conveyor belt which is moving with an acceleration, that is m into a here. M into a. And force due to static friction is mu s into n. I should write mu s because static. Man is under at rest. Mu s into n. N means normal reaction, that is m into g. So what cancels here? M cancels. Therefore, the maximum acceleration that a conveyor belt can have, that is equal to mu s into g, dear students. Mu s 0.2. For a better understanding they will give, means better understanding means to make the simplification easier, g they give 10 meter per second square. Otherwise take 9.8, no matter. So your answer is 2. They are asking acceleration, that is, or you can say 9.8 ಬರೀರಪ್ಪ ಏನಾಗಲ್ಲ, ಕೆಲವೊಂದು ಟೈಮ್ ಕೊಟ್ಟಿರ್ತಾರೆ. If they give 9.8, take 9.8. 0.2 into 9.8. So how much you will get? 19.6. 196 decimal point apply ಮಾಡಿ. So you will get 1.96 meter per second square is the maximum acceleration that is given to a conveyor belt that a person cannot fall. This is concept. A man remains at rest so that the net force on a body should be is equal to 0. Okay. Now every concept what you are learning is very important for the tomorrow, for classes onwards, because you will be in studio class. We will give the question paper along with you, that is assignment will be given. Once you look at the question paper, you must say that these concepts already learnt in regular class. Okay, now don't neglect each and every class. Now say I have something called a contact force between the two objects. Say contact force between the blocks. You take the concepts of contact forces between the blocks. Means, listen here. Let us study in a general way. There is a floor, horizontal floor, on which, say it, assuming that it is a smooth surface, that means coefficient of friction is 0. Say you have two blocks here. Say I give one is 3 kg, another one is 2 kg. When a force of 10 Newton is applied on the two boxes which are in contact, they are asking, first one, find common acceleration and the contact force between them. Contact forces, force you can say, between the blocks. You have this question in your book, dear students. What you are learning, you must have that in your mind. Now, ಏನು ಕಲಿತಾ ಇದೀವಿ ಪ್ಲಸ್ ನಾವು ನಿಮಗೆ ಏನು ಹೇಳ್ಕೊಡ್ತಾ ಇದೀವಿ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್. At the end, you must be saying that we have learned some concepts related to the chapter. Find the common acceleration and the contact force between the blocks. Okay, first you take the diagram. After, along with the diagram, just you must say that this must be taken as a single unit. First thought process. These two blocks which are in contact are taken as a single unit. Of total mass, that is 3 plus 2, you must take that as 5 kg. Then what it says is, this entire 5 kg is applied with what force? 10 Newton. By Newton's second law, that is F is equal to mass into acceleration. That acceleration is F divided by m. This is the common acceleration. Means both 3 kg and 2 kg block move together with a common acceleration. That is, what is the net force acting on it? 10 divided by, that is a 5. So I can say it is 2 meter per second square is the common acceleration. While doing problems at the entrance, be fast. That is the net force 10 divided by 5. That is 2 meter per second square is the common acceleration. Then you have to find contact force. Here only one contact force exists. Say contact force, a single contact force exists. What it is? Listen carefully. We have to write a free body diagram. Free body diagram. We used to say FBD, means what are the real forces that are going to act on a given object. You should write. Don't write your own forces. ನನಗೇನೋ ಒಂದು ಫೋರ್ಸ್ ತಿಳಿತೈತೆ ಎಲ್ಲ ಬರೆಯೋದಲ್ಲ. What are the real forces acting on that individual body? We must write. First, taking 3 kg object. 3 kg object. And I just say when 3 kg is going to push 2 kg, that is, if I say it is an action, 2 kg will exert the same amount of force on the 3 kg. By Newton's third law of motion, to every action there is equal and opposite reaction. When 3 kg push the 2 kg, so here I have two blocks here, 2 kg now and 3 kg. Now for a 2 kg, if let us say F small f, or you can say F1 is the action on 2 kg by 3 kg, by equal and amount and opposite direction, 2 kg will exert same amount of force on 3 kg. If F1 is the action, then F1 is again a reaction on 3 kg, that is by Newton's third law of motion. ಇದನ್ನು ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋ. By Newton's third law of motion, to every action there is equal and opposite reaction. And what are the other forces acting on 3 kg now? They have given, it is a 10 Newton. This is what we say a free body diagram of individual objects. Now, but these are the real forces acting on it. But however, the internal forces for every action and opposite reaction. Here, F1, if I say action, reaction is again same but opposite in direction. I have a common acceleration of how much here? 2 meter per second square. Both objects move with a common acceleration 2 meter per second square. Therefore, just apply Newton's second law on body 2 kg. 2 kg ಗೆ ಇಲ್ಲಿ apply ಮಾಡಿಬಿಟ್ರೆ that F1 is equal to m into a ಆಗುತ್ತೆ. What is the mass here? 2 into 2, that is 4 Newton is the contact force between the two blocks. 4 ಆಪ್ಷನ್ಸ್ ಇರ್ತಾವಲ್ಲ, 4 ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ 2 ಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಸ್ಕ್ವೇರ್ ತೆಗಿಬೇಕು, ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ 4 ನ್ಯೂಟನ್ ಬರೀಬೇಕು. ಈ ಫ್ರೀ ಬಾಡಿ ಸಿಂಗಲ್ ಬಾಡಿ ಇರುತ್ತಲ್ಲ ಅದನ್ನು ತಗೊಂಡು ಬರೆದ್ಬಿಡು, ಲಾಸ್ಟ್ ಬಾಡಿ ಏನಿರುತ್ತಲ್ಲ ಬೇಗ ಮುಗಿದು ಹೋಗುತ್ತೆ ಆನ್ಸರ್. ಹಾಗಿದ್ದಾಗಿ 3 kg ಚೆಕ್ ಮಾಡಿದ್ರೆ 4 ನ್ಯೂಟನ್ ಬರಬೇಕಲ್ವಾ? ಚೆಕ್ ಮಾಡಿ, ವಾಟ್ ಇಸ್ ದ ನೆಟ್ ಫೋರ್ಸ್ ಆಕ್ಟಿಂಗ್ ಆನ್ ದಿಸ್ 3 kg ನಾವು? 3 kgಗೆ ನೆಟ್ ಫೋರ್ಸ್ ಚೆಕ್ ಮಾಡಿದ್ರೆ 10 ನ್ಯೂಟನ್ ರೈಟ್ ಸೈಡ್ ಇದೆ, ಅದಕ್ಕೆ ಆಪೋಸಿಟ್ F1 ಇದೆ. therefore the net force is 10 minus F1. net force is 10 minus F1. that is given by the formula, that is mass into acceleration. 10 minus F1 is equal to, what is the mass of the body here? 3. this is 2, ಈ ಕಡೆ 2 ಬರ್ತಿದ್ದೀವಿ. this one is 2. for 3 kg ಗೆ net force is 10 minus F1. ಇದು ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್. F1 minus 10 ಬರಿಬಾರ್ದು ಅಷ್ಟು ದಡ್ರಿಲ್ಲ ಸರ್, ಜಾಣ್ರದಿರ ಗೊತ್ತು. ಆದರೆ ನೋಡ್ಕೋಬೇಕು, ಕೆಲವು ವಿದ್ಯಾರ್ಥಿಗಳು ನೋಡ್ಬೇಕಲ್ಲ 10 ನ್ಯೂಟನ್ ಈ ಕಡೆ, ಯು ಆರ್ ಅಪ್ಲೈಯಿಂಗ್ ದ 10 ನ್ಯೂಟನ್ ಇನ್ ದ ರೈಟ್ ಸೈಡ್ ಡೈರೆಕ್ಷನ್. the 10 Newton is pushing the object in the right side. therefore 10 Newton is the hero. 10 minus F1, m into a. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ ವಿದ್ಯಾರ್ಥಿಗಳೇ. 3 into, what is the common acceleration here? 2. so 10 minus F1 is equal to 6. solve ಮಾಡ್ತೀಯಾ? F1 is 10 minus 6, again how much you get? 4 Newton. ಸರ್ ಯಾವ್ದು ಸಾಲ್ವ್ ಮಾಡಬೇಕು? ಆಗ್ಲೇ ಹೇಳಿದ್ದೀನಿ, ಲಾಸ್ಟ್ ಬಾಡಿ ಇರುತ್ತಲ್ಲ ಅದನ್ನ ಹಾಕ್ಬಿಡಪ್ಪ. so for every action there is equal and opposite reaction. hence the contact force between the two blocks when they are in contact is how much it is? 4 Newton. Dear students, suppose if this 10 Newton acts on the 2 kg, that is from right to left, does the contact force remain same? Same problem, you can have this. This is what you have studied, you take that as 1 or second problem. Next, the same block I take here, this is 3 kg, other one is 2 kg. now I am applying 10 Newton. Dear students, plenty of problems if you see on the book. This is the basic concept you must know. ಬೇಸಿಕ್ ಇದು ಗೊತ್ತಿದ್ದು ಸಾಕು, ಎಷ್ಟರ ಲೆಕ್ಕ ಮಾಡ್ಕೊ. ಆಮೇಲೆ ಇನ್ನೊಬ್ಬ ಯಾವುದೋ ಮೇಸ್ಟ್ರು ಬಂದು ಹೇಳ್ಕೊಟ್ರು ಕೂಡ ಇದನ್ನ ಚೆನ್ನಾಗಿ ನೆನ್ಪಿಟ್ಕೊಂಡಿರೋ, ನಮ್ಗೆ ಸರ್ ಕಲಿಸಿದ್ರು, ಈಸಿ ಇದೆ ಅಂತ ಹೇಳು. ಓಕೆ, ನಾ ಈಗ 10 Newton ಅಪ್ಲೈ ಮಾಡಿದಾಗ ಆನ್ ವಿಚ್ ಸೈಡ್? ದಟ್ ಈಸ್ ಆನ್ ದ 2 kg. ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಡು ನಾಟ್ ರಿಮೇನ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಈಗಾಗಲೇ ನಮಗೆ ಅಲ್ಲಿ ಎಷ್ಟು 4 Newton ಬಂದಿತ್ತಲ್ಲ, 4 Newton ಬರಲ್ಲ. ಸೊ ಈಗ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅಂದ್ಕೊಂಡು ಕಾಮನ್ ಆಕ್ಸಲರೇಷನ್ ಸ್ವಲ್ಪ ಫಾಸ್ಟಾಗಿ ಚೆಕ್ ಮಾಡಿದ್ರೆ ನೆಟ್ ಫೋರ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ಟೋಟಲ್ ಮಾಸ್. ನೆಟ್ ಫೋರ್ಸ್ ಈಸ್ 10, ಟೋಟಲ್ ಮಾಸ್ ಈಸ್ 3 plus 2, that is 10 by 5. 2 meter per second square remains a constant. Then write the free body diagram. FBD ಬರೆದ್ರೆ ಇಲ್ಲಿ 3 kg ಅನ್ನು ಚೆಕ್ ಮಾಡೋಣ, ಇನ್ನೊಂದು 2 kg ಅನ್ನು ಚೆಕ್ ಮಾಡೋಣ. 2 kg ಎಷ್ಟು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೆಯಾ? 10 ನ್ಯೂಟನ್ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೆಯಾ? ಈಗ 2 kg ದಬ್ಬಿಟ್ರೆ when 2 kg is exerting some force on 3 kg, 3 kg is also exerting some force on 2 kg. ಇದನ್ನ let us call this as F1 here. As action, then F1 becomes what? Reaction. Both are equal and opposite. ಇಲ್ಲಿ ಯಾವ ಲೆಟರ್ ಬರೀತಿ ಅದೇ ಬರ್ಕೊಳ್ಳಪ್ಪ, ಸ್ಮಾಲ್ ಲೆಟರ್ ಬರ್ತಿದ್ದೀನಿ. If one is action, other should be reaction. ಯಾವುದು? ಈ ಫ್ರೀ ಬಾಡಿ ಇದೆ, 3 kg ಮೇಲೆ ಒಂದೇ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಇಲ್ಲಿ ಆಕ್ಸಲರೇಷನ್ ಗೊತ್ತಿದೆ, 2 meter per second square ಗೊತ್ತಿದೆ. therefore F1 is equal to m into a ಬರೀತೀಯ, 3 2s are 6. ಫಿನಿಶ್. 4 ಆಪ್ಷನ್ ಅಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ. ಸೊ ವಾಟ್ ಇಸ್ ದ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಬಿಟ್ವೀನ್ 3 kg and 2 kg? ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಹೆಡ್ಡಿಂಗ್ ಬರ್ದಿದ್ದೀನಪ್ಪ, ಅರ್ಥ ಆಯ್ತು. ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಒಂದೇ, ಇಲ್ಲಿ ಮಾತ್ರ ಒಂದೇ. ಹೌ ಮಚ್ ಯು ಗಾಟ್? 6 Newton. ಸರ್ ಆಗಿದೆ, ಇಲ್ಲಿ ಸೇಮ್ ಇರುತ್ತಾ? ಸೇಮ್ ಇರಲೇಬೇಕು ನೋಡು. ದಟ್ ಈಸ್ ಇಫ್ ಐ ಚೂಸ್ ಆನ್ 2 kg, ಈ ಕಡೆ ಲೆಫ್ಟ್ ಸೈಡ್, ದಿಸ್ ಇಸ್ ದ ಡಾಮಿನೆಂಟ್ ನಾ, 10 Newton ಇಸ್ ದ ಗ್ರೇಟರ್ ಫೋರ್ಸ್. F1 ನೋಡಿ, ಇವೆರಡು ಚೆಕ್ ಮಾಡಿದ್ರೆ, ಇವೆರಡು ಆರೋ ಮಾರ್ಕ್ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಆಪೋಸಿಟ್ ಇದೆ ಅಪ್ಪ, ಆಪೋಸಿಟ್ ಇದೆ, ಆಡ್ ಆಗಲ್ಲ, ಸಬ್ಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. ನೆಟ್ ಫೋರ್ಸ್ 10 minus F1 is equal to 2 into A, m into A ಬರೀತೀಯ. ಯಾವ ಬಾಡಿ ಮೇಲೆ ಬರೀತಾ ಇದೆಯಾ? 2 kg ಬರೀತಾ ಇದೆಯಾ? ಇಂಪಾರ್ಟೆಂಟ್. ಹೌದು ಸರ್. 10 minus F1 is equal to, what is m here? 2. What is the acceleration given? The acceleration is same here. How much? 2. 2 2s are 4. ಇದು 4 ಬರುತ್ತೆ. ಆ ಕಡೆ ಈ ಕಡೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡೋ. F1 is equal to 10 minus 4. How much you will get, dear students? 6 Newton. ಸರ್, ಎರಡು ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ, ಫಾರ್ ಎವ್ರಿ ಆಕ್ಷನ್ ದೇರ್ ಇಸ್ ಈಕ್ವಲ್ ಅಂಡ್ ಆಪೋಸಿಟ್ ರಿಯಾಕ್ಷನ್. ಎರಡು ಸೇಮ್ ಬರ್ತವೆ. ಯಾವುದು ತಗೋಬೇಕು ಫಸ್ಟ್? ಈಸಿ ಇರೋದಕ್ಕೆ ಸಿಂಗಲ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತಲ್ಲ ಅದನ್ನು ತಗೋ. ಕಾಮನ್ ಆಕ್ಸಲರೇಷನ್ ಬರೀ. ಸರ್ ಅರ್ಥ ಆಗಿದೆ. ಇದೇ ಪ್ರಾಬ್ಲಮ್ ನ ಜನರಲ್ ಏನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ, ಇದು ಮುಗಿಸ್ಬೋಣ, ಎಲ್ಲ ಟೈಪ್ಸ್ ಮುಗಿಸ್ಬೋಣ. ದೇ ಗಿವ್ M1 and M2. They give some force F here. Again they ask contact force. First, common acceleration is what? Net force divided by net mass. Answer mugidappa. Acceleration by Newton's second law, F is equal to ma. A is equal to F divided by m. Total force divided by total mass. If I write like this, total force divided by total mass. F divided by m1 by m2 is the common acceleration. Next is what? Sir, we have to find the contact force between m1 and m2. So write the free body diagram. Free body diagram of say m1. What are the forces here? F is the force. Again, I take m2 here. What are the forces acting on this? F1, if I say action, this is reaction. Then, one more thing you can have that. Yenappa antandre, there will be a normal reaction. As N is balanced with Ng, N normal reaction balances with M2G, you can say acceleration along y direction is 0. N is balancing with M2G, no acceleration along y direction, you can say net force on which direction? Y direction is 0. Net force on y direction is 0, that is, I can say here N is equal to mg. So no acceleration along y direction. You can have that in separate mind. You can. Okay, done. So therefore F1 is equal to m. You can say this is m2 here. M2 into a. What is a? Already common acceleration is solved. So that is equal to m2 divided by m1 plus m2. ನೋಡಿ ಸ್ವಲ್ಪ ಲಾಜಿಕ್ ನೋಡ್ಕೊಳ್ಳಿ. f1 is equal to f1 is equal to m2 divided by m1 plus m2 into f ಬರ್ಬಿಡ್ಬೇಕು. 4 ಆಪ್ಷನ್ ಅಲ್ಲಿ ಕಾನ್ಸೆಪ್ಟ್ ಸೇಮ್. ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್, ಡೋಂಟ್ ಬೈ ಹಾರ್ಟ್. ಬೈ ಹಾರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳಿಕ್ಕೆ 1 ಅಥವಾ 2 ಇಲ್ಲ, ರೂಲ್ ಸಾಕಷ್ಟಿದ್ದಾವೆ. Similarly, one second, I have done a mistake here. What is that? Here f1 both should be equal and opposite direction. Suppose if I solve f1, if I solve this f1, you should get the same answer. Dear students, you will get this. Idin solve madidre what this is, f minus f1 is equal to m1 into what? m1 into a. So f minus f1 is equal to m1 f divided by m1 plus m2. Then solve for f1 here. ಈ ಥರ ಮಾಡೋಣ. f1 is equal to f minus f1a. ಬರ್ಕೊಂಡಿದ್ದೀರಾ? ಸೇಮ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳಲಿಕ್ಕೆ, ಯು ವಿಲ್ ಗೆಟ್ ದ ಸೇಮ್. ಡೋಂಟ್ mistake me that sir is doing the same thing again. You will get the same answer. Say f1 is equal to f minus m1 into what is a here? F divided by m1 plus m2. I told earlier, the first single force that is acting is the best to choose the answer when you have two bodies in contact. So LCM tagaltira, you take the LCM here, m1 plus m2, take f as a common here, cross multiply ಮಾಡ್ತೀಯಾ, m1 plus m2 minus m1. LCM ತೊಳಗೆ ಗೊತ್ತಿದೆ, ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. So how much you will get here? m2f divided by m1 plus m2. It is to show that action and reactions, they are equal in magnitude, opposite in direction, and they act on two different bodies. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀವಿ ಥರ್ಡ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಬೇಕಾದ್ರೆ. For every action there is equal and opposite reaction. Magnitudes are same, opposite in direction, but never cancel. Do not cancel because they act on two different bodies. Okay, sir, suppose if they give 3 objects in contact, you can take this 3 blocks in contact. Take this problem, say m1, let us go with general topics here, m1, m2 and m3. Again, smooth surface, taking friction is equal to 0. Suppose if friction exists, you must extract that force. ಹೇಳ್ಕೊಡ್ತೀನಿ ಆಮೇಲೆ. Opposing force ಬಂದರೆ extract ಮಾಡಬೇಕು, ಹೇಳ್ಕೊಡ್ತೀನಿ. Let us say F is the force applied here. F is the force applied. Done. Now I told you should take this as a single unit. ಬರ್ಕೊಂತ ಹೋಗ್ಬಿಡಿಪ್ಪ. Single unit of total mass F, m1 plus m2 plus m3. Therefore, common acceleration is total force divided by total mass. This is the first answer, common acceleration. As we said, F is equal to ma, that is by Newton's second law. A is equal to F by m, done, which is expressed in terms of meter per second square. First step, that is common acceleration, is over. Then write the free body diagrams. Here, dear students, you will have 2 contact forces. They are like this. ಬರಿತೀನಿ ನೋಡಪ್ಪ, ಒಂದು ಇಲ್ಲಿ ಸಿಗುತ್ತೆ ನೋಡ. Between these two, and last between m2 and m3. You can call this as here f1 ಅಂತ ಅಂದ್ರೆ ಇಲ್ಲೇನು ಬರಿಬೋದು, f2 ಅಂತ ಬರಿಬೋದು. ಫಸ್ಟ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇದೆ M1 M2 ನಡುವೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಇದೆಯಲ್ಲ F1 ಅಂತ ತಗೊಂಡ್ರೆ ಬಿಟ್ವೀನ್ M2 and M3 you can take that as F2 is the contact force. So taking free body diagram separately, as I told, sir, which one is the best? Go to the last, that is M3, free body diagram. This will help you a lot. This is moving with a common acceleration A. There is an action here. F2 is the action. Color check missile ಬರೆದಿದೆ, color check missile ಹೇಳ್ಕೊಡೋಣ. F2 it is. F2 is the contact force between M2 and M3. Now they are asking a contact force F2. Therefore F2 is equal to ಏನು ಬರೀತೀಯಾ, mass into acceleration, M3 into A. M3 as it is. What is A here? Common acceleration, just we have studied, that is F divided by M1 plus M2 plus M3 is the first answer. Contact force between M2 and M3 ಎಷ್ಟು ಈಸಿ ಆಗುತ್ತೆ ಅನ್ನೋದಕ್ಕೆ ಕಾನ್ಫಿಡೆಂಟ್ ಇದ್ದೀರಾ, ಕಲಿತಾ ಇದ್ದೀರಾ, ಕಲಿಸ್ತಾ ಇದ್ದೀನಿ, ಮರೆಯಬೇಡಿ. ಓಕೆ, now F2 ಅಂದ ತಕ್ಷಣ, now if I solve for contact force on M2, I should get the same answer. So free body diagram of M2 ಚೆಕ್ ಮಾಡಿದರೆ ವಿದ್ಯಾರ್ಥಿಗಳೇ, if it is an action, everyone you can have this common contact force diagram on in one line. Here M2 you will get. For M2, if it is an action, then this is a reaction. This M2 is moving with a common acceleration A as we studied, and there is one more contact force that comes here, that is what it is, F1 here. And on M3, if I calculate on the contact force on M3, there is F1 is the reactional force between this is M1 here. Between M1 and M2 contact force is F1, and the applied force is F here. And it is moving with a common acceleration A. Dear students, in one single line have this free body diagram. Free body diagram, FBD anta bariತೀವಿ. I told these are the real picture of forces, real forces, what they are acting. Again I am telling you the normal reaction and the downward weight are balanced here. No acceleration along y direction is 0. So concentrate only along x direction. Okay. Now in order to calculate F1, dear students, we have this formula. You can have this on M1 ಅಥವಾ M2 ಇಲ್ಲಿ ಬರೀಬಹುದು. You can choose any one. Either you choose F1 or either you take M1 or M2 to solve for F1. F2 is already done. F2 is over. Now to find F1, use this M1 free body diagram. F is the dominant here, net force. F minus F1 is equal to force is equal to mass into acceleration. Mass into acceleration. ಅದು ಹೇಳ್ತೇನೆ, ಏನು ಬರಿತಾ ಇದೀವಿ ಅನ್ನೋದು ಇಂಪಾರ್ಟೆಂಟ್. ಫೋರ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು M into A. What is the net force on M1? Capital F minus small f1. Why? Because F is greater than F1. Sir, ಚೆನ್ನಾಗಿ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ನಾವೇ ಅನ್ಕೊಳ್ಳೋದಪ್ಪ, ಅದೇನು ಮಾಡ್ತೀಯ? ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. F1 ಆಲ್ರೆಡಿ F1 ಸಾಲ್ವ್ ಮಾಡಬೇಕು ವಿದ್ಯಾರ್ಥಿಗಳು, F1 ಸಾಲ್ವ್ ಮಾಡಬೇಕು. ಸೊ F1 ಇಸ್ ಈಕ್ವಲ್ ಟು ಇದು ಈ ಕಡೆ, ಇದು ಈ ಕಡೆ, ಕ್ಯಾಪಿಟಲ್ F ಮೈನಸ್ M1 ಇಂಟು ಎ ಬಂತು. ವಾಟ್ ಈಸ್ ಎ? ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ ಕಲ್ತಿದ್ದೀವಿ. F minus M1. Common acceleration is F divided by M1 plus M2 plus M3. ಇಲ್ಲಿ F ಕಾಮನ್ ತಗೋ. Take F common. What is the LCM now? LCM you got M1 plus M2 plus M3. F common tondritiya. One step bariti nodappa. One step for understanding neatly. Kelavaru fast baritarle anta heltira. 1 minus M1 divided by M1 plus M2 plus M3. ವಿದ್ಯಾರ್ಥಿಗಳ ಬೋರ್ಡು ಸಾಕಾಗಲ್ಲ, ಇಲ್ಲಿ ನಾನು F2ನ ಅಳಿಸಿಬಿಡ್ತೀನಿ. F2 ಅಳಿಸಿದ ಮೇಲೆ ನಮಗೆ ಇಲ್ಲಿ F1 ಸಿಗ್ತಾ ಇದೆ. F1 ಇಸ್ ಈಕ್ವಲ್ ಟು, ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊ, ಇಲ್ಲಿ F1 ಇದೆ, ಅದು ಇದು ಬೇಕಾಗುತ್ತೆ, F1 ಬೇಕು, ಇಸ್ ಈಕ್ವಲ್ ಟು ಬರಿತಾ ಇದ್ದೀರಾ. LCM ತಗೋಣ. M1 ಪ್ಲಸ್ M2 ಪ್ಲಸ್ M3 ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ತೀರಾ. ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ ಏನು ಕ್ಯಾನ್ಸಲ್, M1 ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಉಳಿಯೋದು ಒಂದು ಸ್ಟೆಪ್ ಬರೆದ್ಬಿಟ್ಟಿದ್ವಲ್ಲ ಅದಕ್ಕೆ, ಇಂಟು ಕ್ಯಾಪಿಟಲ್ F. ಸೊ ವಾಟ್ ಕ್ಯಾನ್ಸಲ್ಸ್ ಹಿಯರ್? M1 ಕ್ಯಾನ್ಸಲ್ಸ್ ಹಿಯರ್, therefore F1 is equal to M2 plus M3. M1 is equal to M2 plus M3 into the common acceleration. ಒಂದು ಲಾಜಿಕ್ ಬರುತ್ತೆ, ಹೇಳ್ಕೊಡ್ತೀನಿ ಅಷ್ಟೇ. ಅದು M1 ಕ್ಯಾನ್ಸಲ್ ಆಗಿದ್ದು ಗೊತ್ತಾಯ್ತು, M1 ಕ್ಯಾನ್ಸಲ್ ಆಗಿದ್ದು ಗೊತ್ತಾಯ್ತು. ಈಗ M2 plus M3 into acceleration. Mass into acceleration. What is acceleration? F divided by M1 plus M2 plus M3. There is one simple trick that you can find F1 easily after learning this. ಇದನ್ನು ಕಲಿತ ಮೇಲೆ ಒಂದು ಚಿಕ್ಕದಾಗಿ ಚೊಕ್ಕದಾಗಿ ಒಂದು ಫಾರ್ಮುಲಾನ ಮೆಮೊರೈಸ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ನನ್ನ ಜೊತೆ ಬರ್ಕೊಂಡಿದ್ದೀರಾ ಅಂತ ತಿಳ್ಕೊಂಡು, after studying this, once you are at the entrance, if you have forgotten every steps, you have to go through the basic principles. ಬೇಸಿಕ್ ಬರ್ಕೊಂಡು ಈ ಥರ ಸಾಲ್ವ್ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ಒಂದು ಕನ್ಕ್ಲೂಷನ್ ಕೊಡ್ತೀನಿ, ಸರಿಯಾಗಿ ನೆನಪಿಟ್ಟುಕೊಳ್ಳಿ. ಎಲ್ಲರೂ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ. M1, M2, M3 ಇಲ್ಲಿ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ಯಾ? ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ ಪಟ್ ಅಂತ ಬರೆಯೋದು ಗೊತ್ತಿರಬೇಕು. ಈಗ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ಗಳು ಎಲ್ಲೆಲ್ಲಿ ಬರ್ತವೆ? ಇಲ್ಲೊಂದು ಬರುತ್ತೆ, F1 ಆಗಲ್ಲಿ ಬರ್ದಿದ್ದೇ ಬರಿತಾ ಇದೆ, F2. ಈಗ ಎಲ್ಲರೂ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ F1 ಬಿಟ್ವೀನ್ M1 and M2 ಅಂತ ಕೇಳಿದೆ. M1 and M2 ಇದೇ ಫಾರ್ಮುಲಾ ಎಷ್ಟು ಫಾಸ್ಟ್ ಬರೀತೀವಿ ನೋಡಿದೆ. F1 ಎಲ್ಲ ಆಕ್ಟ್ ಆಗ್ತದೆ, ಬಿಟ್ವೀನ್ M1 and M2 ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆಯಲ್ಲ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇದನ್ನ ಒಂದು ಕಾಮನ್ ಯೂನಿಟ್ ಅಂತ ತಗೊಂಡ್ಬಿಡ್ಬೇಕು. M2 and M3, M2 plus M3 as taken as single unit. ಭಾಳ ಕೇರ್ಫುಲ್ ಆಗಿ. F1 is the contact force between M1 and M2 ಇದೆ ಅಂದರೆ M1 ಬಿಟ್ಟು ಈ ರೈಟ್ ಸೈಡ್ M2 ಮತ್ತು M3 ನ ಕಾಮನ್ ಬ್ಲಾಕ್ ಅಂತ ತಗೊಂಡ್ಬಿಟ್ಟು the contact force F1 will be is equal to mass into acceleration. Mass of this, mass ಅಂದರೆ M2 plus M3 ಅಂದರೆ if you are calculating the contact force on M1 ಇತ್ತಂದ್ರೆ ರೈಟ್ ಸೈಡ್ ಯಾವುದಿದೆ? M2 plus M3 into common acceleration. Common acceleration is what? Already we have studied net force divided by the net mass. Finish. If you learn this within 10 seconds you can answer. I think you understood clearly. ಎಲ್ಲ ಡೆರಿವೇಶನ್ ಎಲ್ಲ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ. ಹೆಂಗೆ M3 ಚೆಕ್ ಮಾಡಿದ್ರೆ ಎಲ್ಲರೂ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಆನ್ M3 ಕೇಳಿದ್ರೆ ತುಂಬ ಈಸಿ ಇರುತ್ತೆ. M3 ಚೆಕ್ ಮಾಡಿದ್ರೆ ಒಂದೇ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಬರುತ್ತೆ, ಯಾವುದದು? F2 ಬರುತ್ತೆ. F2 ಚೆಕ್ ಮಾಡಿದ್ರೆ ಯು ಆರ್ ಗೆಟಿಂಗ್ ಓನ್ಲಿ ಆನ್ M3 ಓನ್ಲಿ. ದೇರ್ ಫೋರ್ this is common acceleration, ಗೊತ್ತಿದೆ ಎಲ್ರಿಗೂ ಗೊತ್ತಿದೆ. So contact force F2 is equal to mass into acceleration. Mass into acceleration. M3 into ಏನು ಬರೆಯೋಣ? F divided by M1 plus M2 plus M3. Within 10 seconds you can choose the answer. You can have this as a shortcut idea. Shortcut idea. You can have this JBI shortcut idea. ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ ಬಂದಿರುತ್ತಪ್ಪ ಅಷ್ಟೇ, ಬೇರೆ ಏನಿಲ್ಲ. ಬೇಗ ಒಂದು 10 ಸೆಕೆಂಡಲ್ಲಿ ಆನ್ಸರ್ ಮಾಡ್ಬೇಕು ಎಕ್ಸಾಮಲ್ಲಿ. ಬರುತ್ತೆ, ನಿಮಗೆ ಖುಷಿ ಆಗುತ್ತೆ, ಬರುತ್ತೆ, ಈಸಿ ಇರ್ತವೆ. ಬರ್ಕೊಂಡಿದ್ದೀರಾ? Now, dear students, you have to attend the same problem and write the formula directly when this F is applied on this face. Iga F total force is acted on M3. Can you write this M1 here? F1 ಮತ್ತೆ F2 ಇದೆ. Correct ನಿಧಾನಕ್ಕೆ ಬರೆಯೋಣ. Again you can write this. Write neatly and correctly. Don't be in a hurry here. Question is this: find the contact force between the blocks. Find the contact forces between the blocks. Now I have this M3 here, M1 here, or M2 here, and M1. Or else M1, M2, M3 ಕೊಟ್ಟಿದ್ವಿ, ಹಾಗೆ ಬರೆಯೋಣ. ಆಗ ಪ್ರೀವಿಯಸ್ ಪ್ರಾಬ್ಲಮ್ ಏನು ಕೊಟ್ಟಿದ್ದೆ ಅದು M1, M2, M3. Now the force is applied here. Again, as I said, take the contact forces here. You can have your own letters here. If I say the contact force between M2 and M3, ಇಲ್ಲಿ ಫಸ್ಟ್ ಚೆಕ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಇಲ್ಲಿ ಚೆಕ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಫಸ್ಟ್ F1 ಬರೆದಿದ್ದೀವಿ, F1 ಇರಲಿ, ಇದು ಈ ಕಡೆ F2 ಬರೆದಿದ್ದೀವಿ, F2 ಇರಲಿ. ಓಕೆ, ಡನ್. ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ ಬರೆದಿದೆಯಾ? ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬಾರ್ದು ಅಂತ. ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್, ವಾಟ್ ಇಸ್ ದಟ್? ನೆಟ್ ಫೋರ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ದಿಸ್ ಎಂಟೈರ್ 3 should be taken as a single block here, M1 plus M2 plus M3 over. Now take the free body diagram. No need to write the free body diagram, dear students. As I told, M1 is a single block here between contact force that is F1 between M1 and M2. If I choose M1 separately, M2 ಮತ್ತೆ M3 ಇಲ್ಲ ಅಂತ ಇಟ್ಕೋಬೇಕು. Free body diagram ಬೇಕಿದ್ರೆ, I told not necessary. Your answer F1 is that is M1 into common acceleration. M1 into F divided by M1 plus M2 plus M3 is the answer, dear students. This is over on M1. If you want the explanation, take the free body diagram of M1 here. M1 ಅಷ್ಟೇ ತಗೋಬೇಕು. For every action there is equal and opposite reaction. If F1 ಚೆಕ್ ಮಾಡಿದ್ರೆ ಈ ಕಡೆ ಪಕ್ಕಕ್ಕೆ F1 ಇರುತ್ತೆ, ಅದು ಬಿಡು. ನನಗೆ ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ A ಇದೆ. ಸೊ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ F1 ಆನ್ M1 is mass into acceleration. Mass into acceleration. ಇಲ್ಲಿ ಈ ಕಡೆ ಯಾರಿದ್ದಾರೆ? M2 ಇರ್ತಾರೆ. ಮತ್ತೆ ಬಿಟ್ವೀನ್ M1 and M2 ಕಾಣಿಸ್ತಾ ಇದೆ. ಬಿಟ್ವೀನ್ M1 and M2 ಚೆಕ್ ಮಾಡಿದ್ರೆ F1 ನೀಟಾಗಿ ಹೇಳ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ಕಲಿತಾ ಇದ್ದೀರಾ. ಕೆಲವರು ತುಂಬ ಎಂಜಾಯ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಎಲ್ಲರೂ ಎಂಜಾಯ್ ಮಾಡಿ. ಈಗ ಬೈ ಲುಕಿಂಗ್ ಅಟ್ ದ ಬೋರ್ಡ್ ಇಟ್ ಸೆಲ್ಫ್ F2 ಸಾಲ್ವ್ ಮಾಡಬೇಕಿಲ್ಲಿ. F2 ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ನಾನು ಹೇಳಿದ್ದೀನಿ ಏನಂತ, in order to solve F2, choose M1 and M2 as a single unit. M1 plus M2 should be taken as a single unit. So what is the acceleration on this? That is, common acceleration will be there. So therefore contact force F2 will be is equal to mass. ನೋಡಪ್ಪ ಇಲ್ಲಿ contact force ಈಗ ಇದನ್ನ ಚೆಕ್ ಮಾಡಿದ್ರೆ M3 ತೆಗೆದುಬಿಡು. F2 is acting on M1 and M2. ಸರಿ ಗೊತ್ತಾಗ್ಲಿ ಅಂತ ವಿದ್ಯಾರ್ಥಿಗಳೇ, M1 ಬ್ಲಾಕ್ ಇದೆ, M2 ಬ್ಲಾಕ್ ಇದೆಯಲ್ಲ, ಯು ಟೇಕ್ ದಟ್ ಆಸ್ ಅ ಸಿಂಗಲ್ ಯೂನಿಟ್. ಇಲ್ಲಿ M3 ಇದೆ, ಹೌದಾ? ಈಗ ನಮಗೆ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಬರ್ತಾ ಇದೆ, ಯಾವುದದು? ಐ ಜಸ್ಟ್ ಟೋಲ್ಡ್ ದಟ್ ಆಸ್ F2 ಅಂತ ಬರ್ಕೊಂಡಿದ್ದೀನಿ. ಲೆಟಸ್ ಯಾವ್ದಾರಲ್ಲಪ್ಪ F2 F1 ಇಟ್ ಈಸ್ ಯುವರ್ ಕನ್ವೀನಿಯನ್ಸ್. ಇಲ್ಲಿ F2 ಬರ್ತಾ ಇದೆ. F2 is the contact force here. Already we have solved between M1 and M3 is over now. We are solving the contact force between M2 and M3. Direct answer is M1 plus M2 into common acceleration. So you will get M1 plus M2 into F divided by M1 plus M2 plus M3. Dear students, whether you apply force from left to right or right to left, concept remains the same, but the contact forces will be changed. Okay? With this, dear students, let us write some problems based on this concept in a quick method. You can say in 10 to 20 seconds you can answer. Question is this: find the contact force between the blocks of the system shown below. Take one problem. Number continue ಮಾಡ್ಕೊಳ್ಳಿ. It's your convenience. I give like this: 4 kg, 3 kg, 2 kg. Four kg, say 3 kg, 4 3 7 8. Let us say the force applied here is 24 Newton. And calculate easy and ಕೊಡ್ತಾ ಇರ್ತಾರೆ. Dear students, first the common acceleration. A common is total force divided by total mass. That is 24 divided by 4 plus 3 plus 1. 24 by 4 8. So that is A is equal to 3 meter per second square is the answer. Common acceleration is 3 meter per second square. Now choose according to your knowledge here. Between 4 and 3 kg, there you will have F1 is the contact force here. Between 3 and 1, you will have a contact force F2 here. So straight away, as I told, so F2 is equal to mass into acceleration. What is the mass here? 1 into common acceleration is 3, so 3 Newton. If you want, you can design by wasting the time. 1 kg block, this is A common acceleration, this is F2. Again on 3 kg, you will have action. This F2 is how much it is? 3 Newton. ಬರ್ಕೊಳ್ಳಿಪ್ಪ, ಚೆನ್ನಾಗಿ ಗೊತ್ತಾಗಲಿ. ಇವತ್ತೇ ನೆನಪಿರುತ್ತೆ, ಒಂದು ವರ್ಷ ಆದಮೇಲೆ ಕೂಡ ನೆನ್ಪಿಡ್ಬೇಕು. ಒಂದು ವರ್ಷ ಅಲ್ಲ, 100 ಗಂಟೆ ನೆನ್ಪಿಡ್ಬೇಕು. ಯಾರೋ ಹೇಳ್ಕೊಟ್ಟಿದ್ರಪ್ಪ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಂ, okay. Now 24 ನ್ಯೂಟನ್ ಇಲ್ಲಿ ಹಿಂಗೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ನಾವು ಬಿಟ್ವೀನ್ 4 and 3 ಅಂತ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಆಸ್ ವಿ ಸ್ಟಡಿಡ್ 3 and 1 ಶುಡ್ ಬಿ ಟೇಕನ್ ಆಸ್ 1 ಯೂನಿಟ್ ಹಿಯರ್. 3 ಮತ್ತು 1 ಯೂನಿಟ್ ತಗೊಂಡ್ರೆ ದಟ್ ಈಸ್ F2 is equal to 3 plus 1 into common acceleration. ನೋಡಪ್ಪ ಮುಗಿದೋದು. 4 into what is the common acceleration here? 3. Answer 12 Newton. Contact force between 4 kg and 3 kg. 4 3 allappa. 1 second. This is F2. This is F1. I have showed F1 here. Contact force between 4 and 3 kg. Between 4 kg and 3 kg. This is contact force. ಕ್ರಾಸ್ ಚೆಕ್ ಮಾಡ್ಬೋದಾ? ಕ್ಯಾನ್ ವಿ ಕ್ರಾಸ್ ಚೆಕ್ ವೆದರ್ ಇಟ್ ಈಸ್ ರೈಟ್ ಆರ್ ರಾಂಗ್ ಅಂತ ಅಂದ್ಕೊಳ್ಳಿಕ್ಕೆ ಚೆಕ್ ಮಾಡಪ್ಪ, ಮಾಡಬೇಕು. 4 kg ಬ್ಲಾಕ್ ತಗೋ, ಇಲ್ಲಿ 3 kg ಬ್ಲಾಕ್ ತಗೋ. ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ ಗೊತ್ತಿದೆ. ಇಲ್ಲಿ ಅಪ್ಲೈ ಮಾಡಿರೋ ಫೋರ್ಸ್ 24 ನ್ಯೂಟನ್. ಇಲ್ಲಿ ಎಷ್ಟು ಬಂದಿದೆ? ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ F1 ಇದೆ. ಇಲ್ಲಿ F1 ಇರುತ್ತೆ, ಇಲ್ಲಿ F2 ಇರುತ್ತೆ. ಆಲ್ರೆಡಿ F2 ಇಲ್ಲಿ 3 ನ್ಯೂಟನ್ ಸಾಲ್ವ್ ಮಾಡಿದೆ. ನಾವು ವೆದರ್ ಯು ಟೇಕ್ 4 kg ಆರ್ 3 kg, F1 ಶುಡ್ ಬಿ ಏನು ಬರಬೇಕು? 12 ನ್ಯೂಟನ್ ಬರಬೇಕು. ಬರೆಯೋಣ. ಏನು ಬರೆಯೋಣ? 4 kg ತಗೊಂಡ್ರೆ 24 ಜಾಸ್ತಿ, ನೆಟ್ ಫೋರ್ಸ್ ಈಸ್ ಮೋರ್. 24 minus F1 is equal to mass into common acceleration. 24 minus F1 is, what is the mass here? 4. What was the common acceleration? 3. 3 ಬಂದಿತ್ತು. ನಮಗೆ ಬೇಕಾಗಿದೆ F1 ಆಯಿತು. F1 ಆ ಕಡೆ, ಇದು ಈ ಕಡೆ. 24 minus 12. ಸೊ ಅಗೇನ್ ಯು ಗಾಟ್ ಕ್ರಾಸ್ ವೆರಿಫೈ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಷ್ಟೇ. ಯು ಆರ್ ವೆರಿಫೈಯಿಂಗ್ ವೆದರ್ ದಿಸ್ ಇಸ್ ಟ್ರೂ ಆರ್ ರಾಂಗ್. ನೋಡಿ 10 ಸೆಕೆಂಡ್ ಮುಗಿದ್ಬಿಟ್ಟಿರುತ್ತಲ್ಲ. ಇಲ್ಲ ಸರ್, ನಾನು 3 kg ಚೆಕ್ ಮಾಡಿದ್ರೆ ಕೂಡ F1 ಚೆಕ್ ಮಾಡಿದ್ರೆ ಸೇಮ್ ಬರಬೇಕು. ಹಿಯರ್ ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ ಇರುತ್ತೆ. ಆನ್ 3 kg ಚೆಕ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ನೋಡಪ್ಪ F1 ಮತ್ತು F2 ಅಲ್ಲಿ ಇವೆರಡು ಯಾರೋ ಮಾರ್ಕ್ ನೋಡಿದರೆ ಸ್ಟೂಡೆಂಟ್ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊತಾರೆ. ವಿಚ್ ಒನ್ ಇಸ್ ಬಿಗ್ಗರ್? ನೋ, 24 ನ್ಯೂಟನ್ ಗ್ರೇಟರ್ ಇರೋದ್ರಿಂದ ದಿಸ್ ಪುಷಿಂಗ್ ಇಸ್ ಮೋರ್ ಹಿಯರ್. F1 ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ F2 ಹಿಯರ್. Therefore, F1 minus F2 should be is equal to M into A common. Correct? F1 ಹಂಗೆ ಇರಲಿ. What is F2 here? 3. What is M here? 3 into common acceleration is what? 3. 3 ಆ ಕಡೆ ತಗೊಂಡು ಬಾ. So now you get 9 plus 3, 12 Newton. ಹಿಂಗೆ ವೆರಿಫೈ ಮಾಡ್ಕೊಂತ ಕುತ್ಕೋಬೇಡಿ ಎಕ್ಸಾಮ್ನಾಗ. ಇಲ್ಲಿ ಶಾರ್ಟಾಗಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಿ, ಇದನ್ನು ಬರೀಲೇಬೇಕು. ಇಲ್ಲ ಅಂದರೆ ಈ ಕಾನ್ಸೆಪ್ಟ್ ಇದೆಯಲ್ಲ, ಕಾನ್ಸೆಪ್ಟು ನೀಟಾಗಿ ಬರೀಬೇಕು. ದಟ್ ಶಾರ್ಟ್ಕಟ್ ಕಮ್ಸ್ ಓನ್ಲಿ ಆಫ್ಟರ್ ಲರ್ನಿಂಗ್ ದ ಬೇಸಿಕ್ ಕಾನ್ಸೆಪ್ಟ್ ಥರೋಲಿ. ಅಷ್ಟೇ, ಬೇರೆ ಏನಿಲ್ಲ. ಸಿಕ್ಕಲ್ಲ ಶಾರ್ಟ್ಕಟ್ ಬರೆಯಕ್ಕೆ ಬರಲ್ಲಪ್ಪ. ಹಾಂ, ಓಕೆ. ನಾ ಲೆಟ್ ಅಸ್ ಟ್ರೈ ದ ಸೇಮ್ ಪ್ರಾಬ್ಲಮ್ ಬೈ ಅಪ್ಲೈಯಿಂಗ್ 24 Newton ಆನ್ ದ ರೈಟ್ ಸೈಡ್. Does the contact force remains the same? No, contact forces will change depending on the direction of force applied. Again, question is, find the contact force. Dear students, same, I am giving confidence to you that contact force change based on the direction of force that you are going to apply. ಓಕೆ, ಕೆಲವರು ಫಾಸ್ಟಾಗಿ ಬರೆಯೋರು ಮುಗಿಸ್ಬಿಡೋಣ. ಅಲ್ಲಿ ಸರಿಯಾಗಿ ನೋಡ್ಕೋಬೇಕಲ್ಲಿ ಯಾವುದಾದ್ರು ನೀನು F1 ಅಂತೀಯ, ಅದು ಇಂಪಾರ್ಟೆಂಟ್. ನಾವಿಲ್ಲಿ F1 ಅಂತ ಬರ್ಕೊಂಡಿದ್ವಿ, ಆಲ್ರೆಡಿ ಇದಕ್ಕೆ F1 ಬರ್ಕೊಂಡಿದ್ವಿ. ಟು ಡೆಮಾನ್ಸ್ಟ್ರೇಟ್ ದ್ಯಾಟ್ ದೀಸ್ F1 ಆ್ಯಂಡ್ ಅರ್ಲಿಯರ್ F1 ದೇ ಆರ್ ನಾಟ್ ಸೇಮ್, ಡಿಫರೆಂಟ್ ಇದೆ ಅಂತೇಳಿ ತೋರಿಸ್ಲಿಕ್ಕಷ್ಟೇ. ಇಲ್ಲಿ F2 ಇದೆ. ನಾನು ನಿಮಗೆ ಹೇಳಿದ್ದೆ ಯಾವುದು ಫಾಸ್ಟಾಗಿ ಬರೀಬೇಕಂತ ಹೇಳಿದ್ದೆ, 4 kg ಫಾಸ್ಟಾಗಿ ಬರೀಬೇಕು. ದಟ್ ಈಸ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್. ಬರ್ಕೊಳ್ಳಿ, ನೀಟಾಗಿ ಬರ್ಕೊಳ್ಳಿ. ಫಾಸ್ಟಾಗಿ ಬರೆಯೋರು ಹೇಳ್ಬೇಡಿ. ಫಾಸ್ಟಾಗಿ ಬರೆಯೋರು ಏನು ಹೇಳ್ಬೇಕಪ್ಪ ಅಂದರೆ, ಸರ್ ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ 24/8 ಆಗಲ್ಲಿ ಬರೆದಿದ್ದೀವಿ ಸರ್, 3 meter per second square ಆನ್ 4 kg ಇದೆ. F1 is equal to m into a, 4 into that is 3, that is 12 Newton. On 4 kg. This is the F1 here. Okay. Common acceleration is 3 meter per second square. Force is equal to mass into acceleration, 4 into 3. Now let us solve the contact force between 3 and 1. Between 3 kg and 1 kg. As I told, you are applying in this direction. Here, this should be taken as single unit. Single unit of mass, how much here? 4 plus 3, that is 7 kg should be taken as a common mass here. So therefore, contact force between these two, F2 is equal to mass into acceleration. What is the common mass here? That is 4 plus 3 into common acceleration. ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅನ್ಕೊಂಡು 7 into what is the common acceleration? 3. So I got 21 Newton. Okay, dear students, with this you will have plenty of problems that you will face, that will be given as assignment for you, that you have to work out on your own. I have given some assignment work and I will provide you, we will send you the assignment copy. Looking at that assignment copy, you must solve the problems on this concept. Kalitira anta ankondo last another 5 minutes, dear students. Heading, take the heading, find the tension along the string. Tension along the string. Along the string connected between the body, between the bodies. Take this. Tension is a pulling force. Tension is a pulling force which always acts away from the body. Tension is a contact force, you must take that word. ಬರ್ಸಿದ್ದೀನಿ ಇನ್ನೊಂದ್ಸಲ. Tension is a contact force, always acts away from the body. Let us choose with two bodies which are connected. Dear students, take with me. Say, again assuming that friction is 0, smooth surfaces. Surface is smooth here. And I have another body here. Say, one is say 20 kg, other one is 10 kg. Connected by a string, and it is say pulled by a force of say 200 Newton. ಬರ್ದಿದ್ದೀನಿ ಅಂತಂದ್ರೆ ಇಲ್ಲ. Two objects of 20 kg and 10 kg are pulled by 200 Newton. First thing is common acceleration. Again by Newton's second law, F is equal to ma, a is equal to net force divided by total mass. Or net mass antanu kariತಾರೆ. So therefore, as we studied, common acceleration is, what is the total force here? 200 Newton divided by total mass is 20 plus 10. So 200 divided by 30 cancels. Common acceleration is 20 by 3 meter per second square. 6.7 ಬರಿತೀರಾ, ಬರಿಬೋದು, ಏನು ತೊಂದರೆ ಇಲ್ಲ. 3 6 18 6.66 ಬರ್ತಿದೆ. ರೌಂಡ್ ಆಫ್ ಮಾಡಿಕೊಂಡ್ರೆ 6.7 meter per second square is the common acceleration. Now we must have some knowledge of contact force tara. Here these 20 kg and 10 kg are connected by a string. And whenever you have this string, you must say that it is massless and inextensible. ಅಂದರೆ ಸ್ಟ್ರೆಚ್ ಆಗಲ್ಲ ಅಂತ ತಿಳ್ಕೋಬೇಕು. And massless. Mass of the string is negligible. And they are carried on a smooth surface where coefficient of friction is 0. ಇದ್ರೆ ಏನು ಮಾಡಬೇಕು? ಅಪೋಸಿಂಗ್ ಫೋರ್ಸ್ ಮೈನಸ್ ಮಾಡಬೇಕು. ಆಮೇಲೆ ಹೇಳ್ಕೊಡ್ತೀನಿ. Now we have taken smooth surface where coefficient of friction is 0. Now dear students, listen carefully. As we have studied contact force in the same manner, here we should write tension is a force which always acts away from the body. 10 kg ತಗೊಂಡ್ರೆ which always tension acts away from the body here. This is say T here. T. And for every action there is equivalent opposite reaction. If 10 kg is pulling 20 kg, similarly by the same amount 20 kg will drag 10 kg but in opposite direction. These two tensions are opposite in direction. Then write the free body diagram. After learning this, common acceleration is 20/3 meter per second square. Okay, dear students, you have taken this. I am just removing this because I need a space here. First, take a free body diagram of which 20 kg. Here, tension acts away from the body, acceleration is common, tension is nothing but a force. Therefore, tension is a force here, mass into acceleration. Nodappa, innonsala. Tension is a contact force. Force which always acts away from the body. Contact force, underline marka. Force and takshana, mass into acceleration. What is the mass here? 20. What is the acceleration? 20/3. So that you get 400/3 Newton. Amal bekare simplify ಮಾಡ್ಕೊಳ್ಳಿಪ್ಪ. I told you take the single body where a single force is acting. This is enough now. If I say this is action here, another body was 10 kg which was dragged with 200 Newton. And there is a pulling force T. If this T is a action, T is a reaction. For every action there is equal and opposite reaction. So ಇಲ್ಲಿ ಕೂಡ T ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ಸೇಮ್ ಬರಬೇಕು. ಯಾವುದಾದ್ರೂ ಒಂದು ಸಾಲ್ವ್ ಮಾಡಿ ಅಂತ ಇದ್ದೀನಿ. ಜಸ್ಟ್ ಟು ಹ್ಯಾವ್ ಎ ಕಾನ್ಫಿಡೆನ್ಸ್ ಸಾಲ್ವ್ ಮಾಡೋ ಅಪ್ಲೈ ಮಾಡೋದು ಗೊತ್ತಿರಬೇಕು. ಈಗ ಎಲ್ಲರೂ ನೋಡಿಲ್ಲ, T - 200 ಬರೀತೀಯೋ 200 - T ಬರೀತೀಯೋ? Which one is bigger here, dear students? The system is a drag. The system is a drag towards right side. Means acceleration is towards right side. Andre ee case alli 200 Newton is greater than tension irodrinda artha aithalva. So net force again 200 minus T. Idenidu force is equal to mass into acceleration. ಏನು ಸರ್ ಹೇಳ್ತೀರಾ? ಹಂಗೆ ಮತ್ತು ನೀವು ಹಂಗೆ 200 - T ಇಷ್ಟೆಲ್ಲ ಹೇಳ್ಕೊಟ್ಟಿರ್ತೀವಿ. ಒಬ್ಬೊಬ್ಬರು ಒಂದು ಸಣ್ಣ ಲೆಕ್ಕ ಮಾಡಲ್ಲ, ಅವಾಗ ಏನು ಮಾಡಬೇಕು? ಎಲ್ಲ ಜಜ್ಕೋಬೇಕು. ಬೇಡ ಸರ್. 200 - T is equal to m ಅಂದರೆ ಎಷ್ಟಪ್ಪ? 10 into what is the acceleration given here? 20/3. ಸಾಲ್ವ್ ಮಾಡು. ಎಷ್ಟು ಬರಬೇಕು? ಸೇಮ್ ಬರಬೇಕು. ಬರುತ್ತೆ, ಯಾಕೆ ಬರಲ್ಲ? ಸೊ ನಾವು ಯು ಗೆಟ್ 200 - T is equal to 200/3 ಬರುತ್ತೆ. ಇದನ್ನ ಆ ಕಡೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದರೆ 200 - 200/3 600 - 200/3. Dear students, we got the same. As I told earlier, you take the single body where single force is acting. ಅದು ಈಸಿ ಆಗಿಬಿಡುತ್ತಪ್ಪ. ಇದು ಕರೆಕ್ಟೇ, ಬಟ್ ಏನಾಯ್ತು ಸ್ವಲ್ಪ ಟೈಮ್ ತಗೊಳುತ್ತೆ. Okay. ಈಗ same problem if 200 Newton is applied on the left side, do this tension remain same? No. Again dear students, after learning this, calculate same tension when this system is given like this. What are these? 10 kg and other this was 20 kg. Earlier we got contact force as 400 by 3 Newton. In the previous problem we got. Does this remain same? No. Start doing a calculation. Common acceleration, net force divided by net mass. Force is 200 divided by 30, cancel. 20 by 3 meter per second square. Now which body you refer? If you take the free body where you will have only one force, that is free body diagram of 10 kg. It is dragged. Say for example, if I say there is for every action there is equal and opposite reaction, we need to write the tension. 10 kg away from, it acts away from the body, away from the body. 20 kg check ಮಾಡಿದ್ರೆ acts away from the body. ಬರೀ 10 kg ಎಷ್ಟು ತಗೊಂಡ್ರೆ ಚೆಕ್ ಮಾಡಿ. ಮತ್ತೆ ಯಾರೋ ಮಾರ್ಕ್ ಬರೆದಿರ್ತೀವಲ್ಲ, ಬರಿಬೇಕಾದಾಗ ಹಿಂಗೆ ಬರೆದ್ಬಿಡಬೇಡಿ. ಟೆನ್ಷನ್ ಹಿಂಗೆ ತೋರಿಸಿದ್ರೆ ತಪ್ಪಾಗುತ್ತೆ. ಟೆನ್ಷನ್ ಆಲ್ವೇಸ್ ಆಕ್ಟ್ಸ್ ಅವೇ ಫ್ರಮ್ ದ ಬಾಡಿ. ಗೊತ್ತು ಸರ್? ಕಾಮನ್ ಎಕ್ಸಲರೇಷನ್ ಗೊತ್ತಿದೆ. ಸೊ ವಾಟ್ ಇಸ್ ದ ಟೆನ್ಷನ್ ನಾವು? ಟೆನ್ಷನ್ ಇಸ್ ದ ಫೋರ್ಸ್. ವಾಟ್ ಇಸ್ ದ ಫಾರ್ಮುಲಾ? ಮಾಸ್ ಇಂಟು ಆಕ್ಸಲರೇಷನ್. ವಾಟ್ ಇಸ್ ದ ಮಾಸ್ ಹಿಯರ್? 10. What is the acceleration? That is 20 by 3. How much you got? 200 by 3 Newton. Does that contact force remain same? No. ಅರ್ಥ ಆಗಿದೆ. ಅದೇ ರೀತಿ 20 kg ಗೆ ಸಪರೇಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಳ್ಳಿಪ್ಪ ನಿಮ್ಮ ಮನೆಯಲ್ಲೇ ಸಪರೇಟ್ ಮಾಡ್ಕೊಂಡು ಯು ವಿಲ್ ಗೆಟ್ ದಿ ಸೇಮ್ ಆನ್ಸರ್. If you have 3 bodies which are connected, last today class, let us wind up today's session, dear students. So let us say it is dragged by 100 Newton of say 5 kg, 5, 3, 8, 8, 2, 10. 3 bodies are connected by a string dragged by 100 Newton. Calculate tension along the string connected between the bodies here. String is massless and inextensible. Barita hogona. Common acceleration is what? Net force divided by total mass. What is the net force here? 100 divided by 5 plus 3 plus 2, 100 divided by 10, so you get 10 meter per second square is the answer. Now you take a free body diagram separately and apply the contact forces here. Here 5 kg is pulled right side. Tension is away from, let us call this as a T1 here. Here also T1. Between 3 kg and 2 kg, 3 kg is dragged here, that is away from the 3 kg. For 2, away from the body, T2. With this, dear students, which one you prefer? As I told, take 2 kg separately. Free body diagram of 2 kg ಬರೆದ್ರೆ ಈಸಿ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿತ್ತು. 2 kg ಇದು acceleration, ಇದು tension. T2 ಇದು, ಸಾರಿ T2 ಹೇಳಿ ಬರೋಣ. ಏನು ಹೇಳ್ಬೇಕು ಸರ್? That T2 is equal to, tension is the force here, is equal to mass into acceleration. ಈಸಿ ಆಗಿದೆ ಅಂತ ಹೇಳಿ ಒಂದು 5 ನಿಮಿಷ ಎಕ್ಸ್ಟ್ರಾ ತೊಗೊಂಡಿದ್ದೇನೆ. ಮಾಸ್ 2 into acceleration ಎಷ್ಟಾಯಿತು? That is 10. You got 10 meter per second square. So that is 2 into 10, T2 is equal to 20 Newton. Tension between 3 kg and 2 kg. ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀರಾ, ಡಯಾಗ್ರಾಮ್ ಬರ್ದಿದ್ದೀರಾ. ಟೆನ್ಷನ್ along the string connected between 3 kg and 2 kg. ಹಾಗೆ ಯಾವ್ದು ತಗೋಣ? T1 ತಗೋಣ. Take the free body diagram of this. Free body diagram of say 5 kg. What is the tension force here? T2. Tension acts away from the body. ಈ ನೋಡಲ್ಲ, ಎಲ್ಲೋ ಲೈನ್ ಬರ್ದಿದ್ದೆ ನಾನು ಆಗಲೇ. ಎಲ್ಲೋ ಲೈನ್ ಬರ್ದಾಗ ಇದನ್ನ ಅಳಿಸ್ಬಿಟ್ಟು ಹಿಂಗೆ ಬರೀಬೇಕಾ? ತಪ್ಪು ಅಂತ ಹೇಳ್ಬಿಡ್ಬೇಕು ನೀನು. ಈ T2 ಬರುತ್ತೆ, ಯಾರಿಗೆ T2 ಬರುತ್ತೆ? ಯಾರು ಇಲ್ಲಿ ಪಕ್ಕಕ್ಕೆ ಇದ್ದು ನೋಡು, ಯಾವನು 3 kg ಇದ್ದ. 3 kgಗೆ ಆ ಟೆನ್ಷನ್ ಫೋರ್ಸ್ ಬರೆದ್ರೆ ವಿಚ್ ಆಕ್ಟ್ಸ್ ಅವೇ ಫ್ರಮ್ ದ ಬಾಡಿ. ಈ ತಪ್ಪು ಮಾಡಬಾರ್ದು ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಷ್ಟೇ. ಇದು T2. ಈ ಕಡೆ ಚೆಕ್ ಮಾಡಿದ್ರೆ ಯಾವ್ದು ಬಂದಿತ್ತು? ಒಂದು ಸೆಕೆಂಡ್, ಅದು T2 ಆಗಿದೆ, ಇದು T1 ಆಗುತ್ತಪ್ಪ, ಸಾರಿ, ಇದು T2 ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀವಲ್ಲ. ಓಕೆ, ನಾ ಟೇಕ್ ಎನಿ ಒನ್ ಆಫ್ ದಿಸ್. T1 ಬರ್ಕೊಂಡಿದೆಯಾ? ಯಾವುದು? ವಿಚ್ ಒನ್ ಈಸ್ ಬಿಗರ್ ಇಯರ್? 100 Newton is greater here because it is dragged on the left side. 100 Newton greater than T1. Start. 100 minus T1. ಅರ್ಥ ಆಗಿದೆ? It is a force. Force is mass into acceleration. 100 minus T1 is equal to, what is M1 here? 5 kg. What is the common acceleration? 10. Solve ಮಾಡ್ತೀರಾ, 50 ಆಗುತ್ತೆ. Therefore T1 is equal to 100 minus 50. So you will get 50 Newton. Dear students, you try the same on 3 kg. How much here? It is T1. For 3 kg you must get 50 Newton. ಅರ್ಥ ಆಗಿದೆ ಅಂತ ಅಂದ್ಕೊಂಡು ಮತ್ತೆ ಹೋಮ್ವರ್ಕ್ ಕೊಡ್ತೀನಿ, ಹೆದರಬೇಡಿ. ಸೇಮ್ ಡಯಾಗ್ರಾಮಿಗೆ 100 Newton ಇದೆಯಲ್ಲ ಈ ಕಡೆ ರೈಟ್ ಸೈಡಾಗಿ, ಯು ಶುಡ್ ಅಪ್ಲೈ 100 Newton ಆನ್ ದಿಸ್ 2 kg. Calculate the tension, they never remain constant. I have taken some 10 minutes extra. If you have felt burden, just pause at the middle, take the lesson, and in the next day whenever you feel free, take those concepts. Okay, thank you, take care.